In this question, we're dealing with current and resistance, and we're trying to find power. So, a man wishes to vacuum his car with a canister vacuum cleaner marked at 535 watts at 120 volts. This car is parked far from the building, so he uses an extension cord of 15 meters to plug the cleaner into a 120 volt source outlet. Assume the cleaner has constant resistance. So, they say if the resistance of each of the two conductors in the extension cord is 0.9 ohms, what is the actual power delivered to the cleaner? So as in, it's rated at 535, but once you add the resistance, what is it going to actually be? So, in order to solve this, you can go ahead and say that the resistance of the vacuum cleaner only is going to be solved. We can use a power equation, right? So power is going to be equal to voltage squared divided by resistance. And in order to find the resistance, we can just rearrange this and solve for R. So move the R here and bring the P down here, right? So once we do that, we can plug in what we know. And we know that 120 volts is our power source, and our rated power is at 535 watts. So we can find the resistance. And our resistance of the vacuum cleaner is 26.92 ohms. Then we can also add in the resistance from the cord, right? So that's going to be two cords at 0.9 amps, at 0.9 ohms. And that's going to give us 1.8 ohms. So to get the total resistance, we can simply add the resistances because they're in series. So 1.80 ohms plus 26.9 is going to give you a total of 28.72 ohms resistance. Now, it's asking us the actual power. So from here, the strategic way would be, using Ohm's law, you can say that voltage is equal to current times resistance. So in essence, what we can do is we can find the current, and we know the we're going to be able to find the current using rearranging the equation for current is equal to the voltage divided by the resistance. And after that, we can plug in what we know. So we know that our total resistance is 28.72, voltage is 120 source. And we're going to get a current when we're using the vacuum cleaner with the extension cords at 4.18 amps. So from here, what we can say is that power is going to be equal to the current squared times resistance. And what we can say is we know the current that we're going to be using, and that's dependent on the resistance to get your power. So if you plug in the current we just found with the resistance, which is 4.18, and we square that, and you multiply that by the resistance of the vacuum cleaner, because the vacuum cleaner is going to be using that current at 4.18 with the resistance, you're going to get an actual power of 470 watts. Okay, so the actual power with that current given the resistance that we added from the extension cords, we dropped our power, right? So we dropped it to 470 watts. Now, the second question goes a little deeper. So it's going to ask you to find instead, if you want the power to be at least 525 watts, then what must the diameter be of each of the two identical copper conductors in the cord? So in this case, we can rearrange the power equation and solve for the current like we did in the first part. So we can do what we did in the first one, solve for the current. So here we know that we need a 525 watt power rating, and we know the resistance of our vacuum cleaner. So we can just square that to get the actual current, which is going to be a 4.42 amps. So this is the type of current we're going to need to recreate in order if we want 525 watt rating. So from here, strategically what we can say is we can rearrange the Ohm's law and get the resistance equal to the voltage divided by our current. And we know our voltage and we know the current that we need now, so we can see what type of a resistance we're going to need, right? So 120 volt source, and we have a current of 4.42 that we got in order to get a 525 watt rating in the vacuum cleaner that has given resistance. And you're going to get a new resistance. So the new resistance is going to be 27.17 ohms. So that's the resistance you're going to need to power a 525 watt vacuum. And from here, so since you found the new resistance, basically what you can do is say that the 27.17 minus the vacuum cleaner is rated at 26.92 that we found in the first part up here. You can say that you need a total from the extension cord's resistance of 0.255 ohms. But since it's two cables, we can just go ahead and divide that by 2 to get each one, and each one would be a resistance of 0.127 ohms. From here, we can use the resistivity, we can find the resistance using the relationship between resistivity and the length divided by the area. So since we know the new resistance that we need, and we can get the resistivity of copper as a given constant, and we know the length is at a 15 meter long cord, and we're just going to solve for area. And from here, it'll be clear what we're going to do. So from here, if we go ahead and insert what we know, and the resistivity of copper is given, and that's going to be given at 1.7 times 10 to the negative 8 ohms per meter. So from here, the length that we need is at a 15 meters, and we're solving for area, and we know the resistance for each cable, right? So that's going to be 0.127 ohms, since we found that right here. So we can just move this here, solve for area. Just go ahead and do that. You're going to get an area of 2.01 times 10 to the negative 6 meters squared. So that's the area, right? But we're actually trying to find the diameter. And what we know is that the area of a circle, which, a cord is basically a circle, cylindrical, is an area of a circle is pi r squared. So from here, so basically what we're trying to say is pi r squared, right? The area that we just found, you can substitute as in the pi r squared is going to equal to the 2.01 times 10 to the negative 6 meters squared. Since we need the diameter, all we need to do is solve for the radius, and we can multiply by 2 because the radius is 1/2 of the diameter. So from here, what we're going to go ahead and do is solve for the radius. So solving for the radius by moving the pi over, and getting the square root to just get a 1r value, square root on both sides. And you're going to get an r radius of 8 times 10 to the negative 4 meters. From here, what you're going to do is just multiply, since r and radius and distance the distance is 2 times the radius. You can just go ahead and multiply that value by 2 to get the answer that we're looking for, which is the distance is going to be, the diameter is going to be 1.6 times 10 to the negative 3 meters, or another way to say that is 1.60 millimeters.